not going to draw them, we're not going to graph one. I'm just going to do one so that we can put some vocabulary on here. They're going to look like a U. They're either going to be upright or they're going to be upside down. They can be anywhere in the coordinate plane. The ones that we do today are going to be centered around the y-axis, but later on, by the sometime next week, they will shift all over the coordinate plane. So when I draw one today, I'm going to do it away from the y-axis. All right, so now that's why I said you don't need rulers, because they're going to be curves. They're going to be U-shapes. All right, this can be called a quadratic. It can be called a parabola. All right, so there's your two vocab words for it. It can be a quadratic. We can call it a parabola. All right, now they will be in certain places, but like I said, this is a rough sketch. Now, there's going to be a point in an upright parabola like this one. There's going to be a point like this. That's going to be referred to as the vertex. And that vertex can either be determined to be either a maximum value or a minimum value. All right, in this one, it's going to be a minimum value because my entire graph does not go below this point. It's an upright parabola, so that's the lowest point on that graph when I sketch it, so I can refer to it as a minimum. All right, if it was an upside down one, it's going to be a max. So on today's assignment, your goal is going to be to identify the vertex as either a minimum or as maximum. So when it's upright like this, all right, we know that it will be a minimum. All right, now the equation, we're going to look at it in function form. So when I write the function form of a parabola, it's going to look like something you're used to seeing. F of x, all right, this part, ax squared plus bx plus c. Okay, take away the equal sign in the f of x, and you should recognize this because we just spent an entire chapter factoring trinomials. When there was a number in front, we did slide and divide. When there was a 1 there, we did the guess and check with the little box. All right, so now instead of factoring it, we're going to put an equals 0 on there, or f of x equals, and then we're going to be able to graph these things. Now, when it's written in this form right here, that is called standard form. So there's another vocab. All right, we've also talked about standard form with our polynomials. When we were adding, subtracting polynomials, we wrote them in standard form because the exponents were in decreasing order. Okay, now you're going to be able to look at this standard form and then decide whether it's going to be upright or upside down, because you're going to take a look at the a coefficient, or that number in front. Okay, that number in front right there. When that number is positive, it's an upright U. When it's negative, it's an upside down U. All right, so back to what I was saying. All right, when this a coefficient, all right, when that number is positive, it's upright. When that number is negative, it's upside down. So when you go to graph these, the first thing you're going to do is you're going to look at this and you're going to make a decision whether it's right side up or upside down. All right, so don't graph a picture upside down when you know this is positive. Don't write it upside, right side up, when it's negative. All right, so simple things like that. Let's go ahead and add an imaginary line down the center going through that vertex. Okay, that line right there is dotted because it's not part of the graph. It's called the axis of symmetry, and it has an equation. Okay, now that point we're going to be able to identify, right? It's a point on the graph. So maybe 1, 2, 3, 4. Let's say it goes through 4 and then 1, 2. Let's say the ordered pair of that point right there is to the right 4 and up 2. So it's 4, 2. All right, if I know the coordinates of that vertex, then I can write the equation of this up and down line. Up and down lines go through the x-axis, and they go through the x-axis at 4. So x equals 4 is the axis of symmetry. Whatever the x-coordinate of the point of the vertex is, that's the equation, and that's how you write it, x equals 4. Okay, so you've got to be able to identify the axis of symmetry. It should go on every graph. All right, every time you graph, you should put that axis of symmetry on there and then label the equation x equals 4. All right, now, whole point of having an axis of symmetry Even though my rough sketch doesn't look like it, it is symmetrical left to right. Okay, so technically, I only need to find some points on the right-hand side. If I find a point here, and I find this point right here, well then I can just say, okay, if this is 2 to the right, then this is going to be 2 to the left. There will be a symmetrical point across from it. So I only have to find half my points to graph this, and then I just go, oh, symmetrical, make it go the same amount apart. Okay, so the graphing is kind of easy. All right, so vocab, standard form. The A coefficient tells you whether it's positive or negative, upright or upside down. This is called vertex. It can be a maximum or a minimum. You got an axis of symmetry, which is the imaginary line in the middle, and you can write the equation. Okay, now how many people have seen this before? Raise your hands. Oh, so that means some other people that did not take Algebra 1 have raised their hands, so that's good. Okay, all right. Did you graph them? Yes. So see, today should be really, really easy. All right, so get a piece of graph paper out. And I'll have to darken this up a little bit to be able to see those lines. Okay, let's suppose we've got, as an example, it says graph. Now, today we're going to do real simple ones. We're going to graph y equals 1/2 x squared. We're not going to do one with the middle term. I could do one with a plus or minus. Okay. On here, +3, -2, whatever. Everything that we do is going to be centered around the y-axis today. We're not going to shift left or right. Now, the way we're going to graph them today is going to be a XY table. Okay, so we're going to create the X column. We're going to make a really wide space in the middle because we're going to use an extended XY table, and we'll put a Y over here. Everything that is to the right-hand side of the equal sign goes in the middle right there. Okay, so 1/2 x squared. Now, since this is a really simple one, and there is no b term at all, and there's no constant over here, we know it's going to be symmetrical around that y-axis. So, for today, you're going to be able to put 0 in the middle, because I know that my axis of symmetry is going to go through 0. All right. Now, technically, I could run some numbers that are negative to the left, run some numbers to the right that are positive, and I'll get both sides. So, I don't know, let's try maybe a 2 here, and then a 4. You don't have to do 1, 2, 3, 4. Everybody in the room could do different ones, but for consistency here, and we all have the same answers, let's do the same ones. All right, if I do a 2, 4 here, I'm going to do a -2 here, I'm going to do a -4 there. Now, when I plug in 0, let's do that because that's going to be our point in the middle. When I plug in 0 for x, I'm going to have 1/2 times 0 squared. What's that answer? 0. Okay, which we knew it was going to go through 0, 0 because of what type of graph it is. So I'm going to put that on there. All right, that's my vertex. It's going to be the vertex. I can look at the leading coefficient. It's a positive 1/2. Is it going to be upright or upside down? Positive, so it's going to be upright, so I know it's going to go up. Now, I don't care whether you do these two or you do these two, but technically I only have to fill out 2 of these. I can get 2 points on here, and then I can just make it symmetrical. Okay, so would you rather do the positive ones or would you rather do the negative ones? Yeah, positive ones are going to be easier. So I'm going to plug 1/2 and then x equals 2. You got to do order of operations. Okay, 2 squared. 2 squared. Let's do this in our head. 2 squared is 4 times 1/2 or divide by 2. 2. So then that gives me the ordered pair 2, 2. All right, I didn't write the ordered pair 0, 0 there. Okay, so I'm going to go from the origin. I'm just going to plot that point. Over 2, up 2, and put a point. Now, I don't have to do the -2 one because, well, I know what the answer is going to be. The answer over here is going to be, not -2. It's going to be 2 because if this point is on the graph and I know this is upright, then I went to the right 2 and up 2, so I know I can go to the left 2 and up 2, and there's going to be that point right there. The ordered pair is -2, 2. So I didn't have to do the math. I know the point's symmetrical. Okay, let's do the 4, 1/2 times 4 squared. Okay, what's 4 squared? 16, half of 16? 8. Alright, so then I've got the ordered pair 4, 8. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I'm just a smudgy bit off my graph paper. You're probably still on your graph paper. Alright, but again, I don't have to do the -4 because I know it had better be also 8 because it's going to be the symmetrical point. So I'm going to go to the left 4. 1, 2, 3, 4. I'm going to go up 8. And that point should be straight across from that because it's symmetrical. Alright, and then there we have it. We've got our parabola. Now, the only thing I can say is when you go to connect these, make sure it's kind of definitely curvy down here at the bottom so that it looks like it's supposed to be a parabola and not one of those V-shaped graphs that we have done. Alright, is the vertex a maximum or a minimum? It's minimum. What have I not added to this? I've not added something to my graph. What do I need to add? I gotta add one more thing. Axis of symmetry goes right through that vertex. It needs to be a dotted line because it's not part of the graph. It's the imaginary axis of symmetry. Alright, now the equation for that axis of symmetry is x equals 0 because it goes through the point 0, 0 at x coordinate 0. Alright, so knowing that you have seen this before helps tremendously. It means we shouldn't have to do tons of examples. Main things today are vocabulary, axis of symmetry, your vertex, whether it's a max or a min, and then can you make an XY table and sketch them. Okay, that's about the only concepts we have to do today.